Hello students, and welcome to the second part of this lesson. In this video, we're going to start to cover the antiderivatives of trig functions and really start to tie together derivatives with their antiderivatives. So let's get started. So we know what the derivative of sine and cosine are, so we really want to write down what the antiderivatives of cosine and sine are. So here we have the antiderivative of cosine of x, so we know that that's going to be sine of x plus c, never forgetting that constant. Then over here we have the antiderivative of sine of x, and that is going to be the negative cosine x plus c. And one thing I didn't mention in the last video, but you might have started to catch on, is that at any of these points, you're able to take the derivative of our result and see if you get that integrand that we started with. So what's the derivative of sine of x? Well, that's cosine of x. And of course, the derivative of constant is plus 0. So we can see that we can go back at any of these points. So now, knowing that information, knowing our trig derivatives, we want to find each of these antiderivatives. So in our first example here, there's no rewriting involved. So what is the antiderivative of sine? Well, that's going to be negative cosine. So I'm going to have that negative go there, still multiplying by the constant cosine of x. And then what's the antiderivative of cosine? And I really just like to say, okay, what function whose derivative gets me cosine? So I know if I had the derivative of sine, that gets me cosine of x. And then of course, we always have the plus c. So go ahead and take a stab at these next three examples and see if you get the same results that I do. All right, and here are the answers that we're going to have. Again, just keep in mind, you can check any of these. If you're not confident starting out, just take your result, right? Just take this result that's right here and take the derivative of that. What's the derivative of 2x squared? Well, that's 4x. And is that what I started with? Yes, so I know I'm doing stuff correctly. So now let's move on to our next part. And in this part, we have information about the second derivative, the derivative, we know specific values. So let's see if we can take this information and get all the way back to that original proper function. So here in this case, we're going to be given information so that we're able to actually find f of x without the plus c. So let's see if we can go all the way back to the beginning. So we're starting here with the second derivative of x. And so if I know if I'm going up from second derivative to the first derivative, that is antiderivative, the integral. So I'm going to find the integral of 2. And since my variable is x, I'm going to say 2 dx. And so from some of the examples that we've done so far, we know that this is going to be 2x plus c. Well, this is going to be f prime of x. We know f prime of 2 is 5. So since I know that information, all right, so because that's what's given here, I can say here 2 times 2 plus c should get me 5. And now I'm able to determine what that constant is. So I know that c comes out to be 1. So now since I know here that f prime of x equals 2x plus 1, because I know that the constant is 1, I can go back up and I can find the next antiderivative. So let's find the antiderivative of 2x plus 1 dx. And so I'm going to find that, and that is going to be x squared plus x plus c. And again, we're given information where we can actually find that constant. So let's substitute 2 in here. So I'm going to get 2 squared plus 2 plus c equals 10. And so that's 4 plus 2, that's 6. So I know that c is going to equal 4. So now I want to find f of x. So we know that this part is going to give us f of x with the constant, and now I know what that constant is. I know that constant is 4. So f of x is going to be x squared plus x plus 4. And because we're given those starter points of f prime of 2 equals 5, of f of 2 equals 10, since we know those values, we can determine what information. We don't need to keep it a random constant. We know specifically what that constant is. And of course, if we were to take the derivative of x squared plus x plus 4, we'd be able to get f prime of x. And if we were to take the derivative of f prime of x, we would get exactly what we started with, right there. So using this example, I want you guys to go ahead and tackle the second example over there and see if you can get that same answer that we're going to get in just a moment. All right, and that right there is going to be what f of x is in our second problem. Don't worry about the square roots. Make sure you're very clear, you're very consistent with how you handle these antiderivatives. Again, start slow, look for more examples of just practicing these antiderivatives over and over again. Moving forward, you really just don't want to keep these in your head about how do I find antiderivatives. You just want them to be very consistent. So hopefully you got these answers here. And of course, if you are confused on any of these problems, please reach out to me. I'm Mr. Hernandez, and this was Mr. Hernandez Teaches.